Hey guys, just doing a video. I'm playing with my new scope here, trying to learn its ins and outs. I like it a lot. First thing, I got a little 555 timer circuit here. I'm going to an LED. You can see as I adjust the charge rate of the cap, it changes the frequency. It's pretty cool. Can adjust that, then adjust the threshold, I think. Anyways, just a 555 timer circuit. Fun stuff. On to the next thing. Alright, so here I got a vortex coil. I got the one probe across the collector and the other probe across the base. The bottom trace is the base. It's on 0.1 volts per division, so we're getting about almost 0.1 of a volt going to the base, and that's the collector on channel B, and it's set on 2 volts per division, so we're getting about 3 volts and a little bit on the collector there. If I change the resistance on the base, it changes the frequency, but also it draws way more current. Let me get this up a bit. See that? Anyways, pretty neat stuff. So yeah, using this I can figure out, the frequency. Running right now like this, the frequency is 33K. It's actually 333.3333. But anyways, I just thought that was pretty cool. That's what the frequency worked out to be for the vortex coil. And on to the next one. So right there is Hector. Right here is a little bit of plasma from this Slayer I got plugged in. Little AC power supply transformer. Running on about 15 volts. 3 feet away, right here, is channel A hooked up just to a little alligator clip, and here is the reading on the alligator. That's the signal that's being transmitted from the Slayer circuit. It's on half a volt per division, so we're having about 1.2 volts, or half a volt, yeah, about 1.2 volts. Wirelessly reaching to channel A, using the divisions on the division scales on here. I was able to figure out the frequency that is being put out by the Slayer, and it was about 769 kilohertz. And you do that by you line up one here and you just count across and see how it meets up on that one. So I'd be okay, let's get this on here. Oh, it lines up. See how they're pretty much lined up end to end. So you count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 cycles over 10 divisions, and it's 1 microsecond per division. So you can then do the math by, well, there's 14 cycles over 10 microseconds, and then you can go on the internet or use a calculator and figure out how many hertz you're getting there. Anyways, that's all. This video was more just to show you my new oscilloscope. I love it. It's a big guy, but I don't know. I'm in love already. Anyways, guys, peace.